Hey guys, today I'm going to solve another one Leetcode challenge, and I'm going to do it for sure with Matt and Mira, our, uh, I would say, AI interviewers, which may help me to study new things on Leetcode. With them, I'm not only study how to solve any task, but also train my ability to discuss this task at the same time, to justify it, and so on. Today I'm going to take a jump game task. It's Leetcode 55. As I told previously, my approach to study Leetcode is to solve task on my own for the first time and then repeat it with Matt and Mira to study not only solving but also discussion. What's probably even more important during the real life interview than just give a solution. This is medium task. I already had several approaches to solve it, so let's see how can I repeat it during our interview. So let's go. Also, besides that, at the end, I will show you one more cool feature of AlgaHug. It's interview feedback. Now, right after getting like a finishing interview, you may receive feedback on your email. So I will show you later. Let's go.
Hey there, welcome. Can you please introduce yourself and tell us a bit about your experience with JavaScript?
Hi, Matt. Nice to meet you again. My experience with JavaScript is around 6 years.
Thanks for sharing that, John. Let's jump right into the problem. Can you explain your approach for solving this problem?
Okay, this jump game, I believe we may run it, we may solve it just in one run when we go through all this array of numbers. And main idea is to understand if some point, if some index in array reachable from position before that. And if it's reachable even from one position, we may return true at the end. But anyway, we need to go through whole array because, for example, if array has 10,000 items, yeah, or something, and all of them, almost all of them are zero, um, but first one is 10,000, that means last one is reachable. I think so.
I see what you're getting at, John, but let's try to break it down a bit further. So, we have an integer array nums, where each element represents the maximum jump length at that position. We are initially positioned at the first index of the array. Can you try to explain, step by step, how you would determine if we can reach the last index? Don't worry about the specific code just yet. Let's focus on the concept first.
Uh, okay, as I said, I want to solve it. It's quite maybe simple way, just in one run. So our complexity will be O from n, and I'm going to start from position which previous before last one, and check if it's more than 0, because if position more than 0 and last one is next, it means that it's the last one is reachable because we need only one jump from this position. Then going to go to next one, previous, and check if position last like one before last one reachable from there. And in such manner, I want to go through each position from last one to first one, checking if it's reachable from at least one position before it.
All right, that makes sense. If I understand you correctly, you're suggesting to start at the second to last index and work backwards to the first index. For each index, we check if it's reachable from the previous indices, and if not, we return false. If we can reach the first index, we return true. Is that correct?
Yes, and besides that, I want to store lengths. Lengths, it's for example, if sum of position is equal to 0, that means we cannot reach next one right from it. But we may reach next one from some previous position, but in this case, like this range would be longer, not one, but for example 2, 3, or something. So I want to store also kind of lengths which we need to overcome to reach last reachable position. Is it clear?
I get the idea. So if we encounter an index with a value of 0, it may not be possible to reach the next index from this one. However, we still may be able to reach the next index from a previous index. So to keep track, you want to store the links to previous positions with greater than 0 values. Is that correct? But just to clarify, these links are only kept for printout later? Our function will still only return true or false based on whether we can reach the last index, right?
Yes, correct. At the end, I want to check if this length is equal to 1 or it's more than 1. Because if it's more than 1, this means that somewhere we have a position we cannot reach. Let me maybe start with code, and I will show you what do I mean.
Sounds good. Let's see what you have so far.
Okay, I want to start with variable length, and this is length equal to 1 because it's a length till next position, and we start from 1. I mean, if we started from position previous before last one, to reach last one, we need only one step.
Okay, I see where you're going with this. Since we start at the second to last index, we know the length of the range is at least 1 to reach the last index. But I would like to know, how are we checking if an index is reachable from the previous indices? Can you maybe explain that step?
Yes, we going backward from last, like one before last position, and go one by one backward. And here we need to check if our item equal to 0, not equal but more than 0. It cannot be less below 0, yeah, because it's always positive number. But we may check if it's just more or it's equal to 0. And if it's equal to 0, we need to increase our length, because it's mean that to reach last reachable position we need overcome lengths more than 1. Like each step increase this length in 1.
I think I follow. So we start from the second to last index and work backwards one index at a time. If the value at an index is greater than 0, we can assume that we can reach the previous index from this one. If the value at an index is 0, then we need to add to the lengths variable. Is that correct?
Yes, I think so. And here, if this number more than 0, we need to check if our number more than length, this means that we may achieve, reach a last reachable position from this one. We just set length back to 1, because in that case we understand that from this particular position we may reach next reachable. And if it's not, we may also increase length, because from this position we cannot reach last reachable, so we need to check next one, but length should be increased.
Right on. So if a number is more than 0, meaning we can make a step, you check if it is more than the current length. If it is, we just reset length to 1. If it not, we have to increment length because we just got to a point where wouldn't be able to achieve the last reachable point, correct? But I am curious about the condition where the number is 0. Isn't this point unreachable? What is your thought process behind this?
If point equal to 0, that means that we cannot reach any other point from this position, because we cannot do any jump from here. So we just check previous one, with smaller index, and check if we may reach from there last reachable position. And I think I finish with coding. Let's run it and see, because if at the end length still equal to 1, that means that from very first position we may reach last one. Let's check.
Great job, John. Let's see if we can go over how your function would solve this jump game problem. So, we start at the second to last index and work our way backwards one index at a time. Each time we check if the value at the current index is greater than 0. If it is, we check if it will allow us to reach the last reachable position. If the value is greater than the current length, then we just reset the length. If not, we increment the length because this is seen as being able to reach the last reachable position from here. If the value is equal to 0, we increment the length. Finally, if the length is still equal to 1 by the end of the loop, we know that we are able to reach the last index. Does that all sound about right?
Yes, absolutely. And I fixed some minor typo in the if statement, because nums I should not be able only more than length, but also equal to length to reach next reachable position.
Awesome. Thanks for clarifying. Will this solution work and solve the problem as expected? Let's test it and see if it passes all the test cases first.
Yes, I see. Maybe it's not very fast, but it's very good from a memory perspective.
Yes, the approach is simple and clear. The time complexity for your solution is O(n), since we go through the entire array once. From a space complexity standpoint, it looks like it's O(1), since we only store a single variable to keep track of the maximum index. Overall, your code logic looks great, John. Thanks for taking us through your thought process.
Okay, guys, it was a pleasure to work with you.
Thanks, John. It was great working with you as well. Before we wrap up, is there anything else you'd like to share or discuss?
No, thank you very much for interview. It was really nice.
You're very welcome, John. It's been great getting to know you better and hearing your ideas. We wish you the best of luck with your job search. Have a great day.
Okay, perfect. And as I told you, I want to show you one more feature of AlgaHack. Let me put on pause this video and go to my email. Okay, let's resume. As you can see, it's give me not very big mark, only 3.5, but let's check why. So we have this task and what's our main justification. Okay, we demonstrated a good understanding of the problem and was able to articulate solutions that would work to solve given problem. We provide explanation, that's good. Approach displayed good problem solving. However, considered code was not a convenient conventional approach, and although it appeared to serve the problem's need, it did not match the expected optimal solution, typically for a jump game problem. Okay, good to know, because it gives us possibility to study a more appropriate solution. You may see that also we have some like improvement that we may take into consideration later. It's very good to know. It's about everything: technical communication, collaboration, and so on. Summarization skill. I will study it a bit later. But let's check. Let's check optimal solution for that. And here it's we have copilot mode, which may help us with that. So what we need to do is just highlight task and run solution to check which to run application to check optimal solution. Okay, it looks quite simple. It has also O from N complexity. Let's put it in instead of my code just to see if it may serve better. Okay, I don't want to say that it's really better than my solution, but maybe we may boost this solution. Boost, it's another feature of AlgaHack. It's allowed to try to get most optimal solution, but it may take more time. And let's see, it says that initial solution is already optimal. It follows the most effective way to serve the task. Okay, let's copy it and check. Not a lot of difference between our previous, but it's also was good. Okay, nice. I will check this solution as well, and come to you next time with next problem to solve. Okay, thank you very much for attention, and see you later. Bye bye.